Okay, no problem.
All right. Okay.
Yeah, by the way, I think I will start with a very quick intro about the company. So after that, I will
Okay.
pass to Speaker Mr. Lau to continue the remaining part for the technical sharing. Will you be fine?
Oh, okay. Sure. Sure. No problems.
Okay, great.
Uh,
Yeah. Yeah, anything?
uh, you are Mingli, is it?
Yes, you're right.
Okay. All right. All right. Okay. Sure. Sure. No problems.
Yeah,
Um,
thanks. Mm.
so you will start with the introductions first, and then after that we go with the Mr. Lau presentation, right?
Yes, you're right. A very
Okay.
quick
All
intro.
right.
Yeah.
So I will be the host for this session anyway.
Okay.
So while we are waiting for the other students to come in, let's just maybe a little bit introduce yourself, maybe, for example.
Maybe introduction from our side.
Yeah.
Okay. Yeah. Okay, so good afternoon, everyone, students, especially students. So, we're actually from Vitrox Corporations. I'm mainly here, a senior HR executive from Vitrox. So mainly actually handling some recruitment itself, and we are having another senior R&D engineer, Mr. Ace Lau, from one of our R&D departments. So he will be actually sharing about his expertise later on to our before. Yeah.
Okay. All right. So we've actually visited Vitrox. I think it was in 2022, if I'm not mistaken.
Oh,
Yeah, there's a group of us
is
that
it the one that hosted you guys?
I think so. I don't really remember, but yeah, I think so. We
Okay,
visited the Vitrox. Yeah,
together with Dr. Sarah.
Stephanie, Dr. Sarah.
Yeah.
So
Yeah.
we really enjoy the, the environments in Vitrox. So
Yeah,
it's
thank
a
you.
very good it's very good environments, and then we share with the students as well regarding Vitrox, and then we actually like the environments, the cultures, Vitrox.
I'm
So
just wonder these batch of students they are from year three.
yeah, I think most there will be mix of I think most of them will be in year 3 because they are looking for internship placement. But I'm sure as well there are few final year students and second year students joining this talk as well.
Oh, I see. Okay.
Yeah.
Because we also recruiting intern
Mm.
from computer science, software engineering,
Yeah.
IT, and etc. Yeah.
Yeah. So maybe this is a good place now for you to maybe introduce the internship programs that you have, for examples. Yeah, you know.
Yes.
Okay. So
Okay.
maybe I think we can start.
Okay.
Good afternoon, everyone. So I just want to have a quick introductions about myself. So my name is Dr. Fazlan. So I'm the program coordinator for software engineering, and also one of the industrial training coordinator, assisting Madam Nur Fauza. And then so one of the goals for today's sessions is basically to have sharing sessions from the talks for our students to to have some opportunities to learn about the company. If you have like an internship programs as well that you might want to introduce, and also from presentations from Mr. Lau Ziwik as well. So I'm sure that our students will learn something from these sessions. Okay, so mainly maybe you want to start first, right?
Yes. Maybe
Yeah.
I start
So yeah, I
first.
will
Yeah.
I will share I will give the sessions to you, lah, right?
Thank you. Share my screen. Okay. Can everyone see my screen?
Yes. Yes.
Okay, great. Okay, so before that, let me share the QR code of our company's social medias. We're actually having various social media that you can see from the screen itself. We have LinkedIn, IG, and Facebook. So if let's say you would like to follow the latest updates regarding of Vitrox, right, you can actually follow us and like our page in this various platform. So you can get to know about the live in Vitrox and also some latest recruitment updates and also some of the company updates as well. Okay, so let us enjoy a couple of
Because
minutes.
of you, we focus on every little detail, exploring every delicate chapter on the journey. We believe everyone is capable of endless possibilities. Follow the vision in every step. We found excitement. With your blessing, we have unlimited strength, bringing out our best and sustaining it at all times. This is important to us. Our essence is most grounded when we are contributing, all of us, at each and every moment, uniting us to walk the right path. As we aid others, we are learning from the trials of everyday life. It recalls us to value the first thing that actually matters. It is you who have made us different. This is our journey towards greatness.
Okay, so yeah, the video that I shared just now is our company corporate video. So if let's say anyone are interested to rewatch again, you can go to YouTube and search Vitrox and you can get more video from there. Not only corporate video and also other videos as well. Sorry. Okay, so as I mentioned just now, introduce myself. I'm mainly over here. I'm actually from People Management Department, which basically is the HR department in Vitrox. So I'm mainly actually handling some recruitments on technical recruitment. So I'm going to share with you a little bit on uh, a quick intro regarding Vitrox today. Okay, before I pass this to Mr. Lau. Okay, so for our purpose in Vitrox, right, is actually to contribute to the advancement of society and well-being of humankind through compassionate innovations, visions that we are working on improving the human life beings through our technologies. Okay, so for our visions and missions, so we actually aim to be the world's most trusted technology company, and for mission wise, we are committing to providing the most innovative, advanced, and cost-effective machine vision solution to our customer. Okay, so let us go through a company overview. So for Vitrox, we are actually a Malaysian Hong Kong technology company, are not MNC. We are a LLC in Malaysia and we established in the year of 2000. So as of now, we are about 23 years old, approximately 24 years old. We are going to start into 24 years old next year. And we are also actually listed under Bursa Malaysia with a stock of 0097. So what basically is the business nature of Vitrox? We are actually focusing on machine vision inspection. So we are delivering a complete range of product and solutions, ranging from back-end semiconductor to PCBs and system on chip embedded electronic solutions and also industrial 4.0 smart solution. And even recent year we penetrate into agriculture and education sector. So maybe you'll be wondering what's the name of Vitrox actually came from, right? So why we name it as Vitrox? Basically, it came from two wording. Okay, the first wording is actually extract from VI. So VI is actually stand for vision, which is our core technology, machine vision. So we extract BI from visions, and file 4, the remaining TRO, is actually from electronics. Okay, so it will be visions plus electronics and actually key out the name of Vitrox, which is a combination of our core technology and also one of our business unit that focusing on electronics will be named as Vitrox. Okay, after getting to know about the very brief information about Vitrox and maybe you'll be wondering how Vitrox actually started the business. Okay, it back to more than 20 years ago. And the story begins with the camera that you see on the screen. Okay, so what is it relates to the establishment of Vitrox? It's basically uh, the story of our founder, lah, which is our CEO, Mr. Chu Jianwei. So during his young age, right, he actually studied at USM, okay, in EE engineering, electrical and electronics engineering. And his family is actually not really doing well. Okay, not really. He not really come from a very wealthy family. So his parents actually didn't able to afford a very cool gadget. Okay, at that point of time, but during one of his birthdays, on during his university time, his mother decided to give him a surprise by purchasing this second-hand camera that you see on the slide itself. Okay, to give it as a birthday present to him. So during the times that he received this present, right, he feel very happy and excited, and he started to research on how to take good photography. Okay, so he went to the library and started to do some research on how to take good photography. Okay, so you may be wondering, how come that when you want to take photography, you need to do some research? It's because that this kind of cameras, right, is required film to capture the image, which is that every capture actually count. So, which means that if I say it's exposed or what, then it is already burned, the particular film. So that's why that he need to do a lot of research in order that he won't waste his money. Okay, so at that point of time, he actually fell in love with photograph, and during his internship time, he had his intern with Hewlett Packard. So one day during his internship, he passed by a manufacturing floor, and he saw that there's a camera performing inspection and mounted on the body. So he was amazed by this technology. After that, he went back to do research to try to discover that what is this technology about. So after some time, uh, after research, he actually found out that his technology on so-called this process that is witness, right, is actually machine vision. And he would like to request for a department transfer to that department to learn further. But unfortunately, there's no headcount at the moment, and he couldn't go for that department for continuous training internship in R&D. But they are looking for someone that can perform soldering. But so he actually went there, even thought it's not R&D related. So after his completed internship, he proposed to have a final year project collaboration with Hewlett Packard related to machine vision. Both of the supervisor agreed to his proposal and he started to work on it. Of course, he able to complete the projects and also getting a very good grading, and eventually he got a job offer from Hewlett Packard without any interview. So you can imagine how impressed he was that time. So this is our founder, Mr. Chu Jianwei. Okay, this is his younger time, young age, during young age. So he visited to the birthplace of Silicon Valley. Okay, so he when the time they attached to Hewlett Packard, he got a training opportunity to visit to the birthplace of Hewlett Packard as well. It's actually a garage over here. The garage is a place that normally you watch a Western movie, they will be parking their car in the house and all those things, right? So that one is considered as garage. So that two graduate they actually started uh, Hewlett Packard's in the founder lah. They started in the garage. So Mr. Chu was actually amazed, impressed by their determination. So he actually have a mindset and the seeds of that become a entrepreneur actually entered into his mind. And if I say that as a child, he would like to pick up. So after he went back, he continued to work as an engineer in Hewlett Packard. one day, one co-founder, Mr. Steven Xiao, actually approached Mr. Zhu and say that share with him that one of the companies perhaps looking for machine vision solution. He's asking whether that he actually will he interested to pick up this opportunity. So Mr. Zhu actually without hesitates, he decided to pick up the opportunity and he quit his job from Hewlett Packard. So he started to work on the project, but unfortunately after a month, they realized that they couldn't complete the project on time because that they have not enough of helping hand to work on the projects. So they decided to hire one more people to help them. Okay, Mr. Chu had an idea candidate and he gave him a call and meet him up in the kopitiam and share with him his plan and all those things. So and at the same time, Mr. Chu also, upfront informing this candidate, he only able to offer him maximum 3 months salary if let's say the startup is not success. So imagine if let's say we receive this kind of offer, right, we will hesitate whether we want to accept it or not. Okay? Because only 3 months. So but for this fresh graduates, right, he actually was an ex-intern that he worked with Mr. Drew at Hewlett Packard before. He actually quite admire Mr. Drew and also um, he feel that even thought if let's say this is not a success for the startup, he can actually search for a new job again. It's no harm for him. Okay. Just for information, the fresh grad is the first class computer science graduate from USM, and he gotten several offers better than Mr. Johnson Finance. But at the end, this fresh graduate, also called Washington, decided to join Mr. Chu. Okay, after that, they work on the project for months and they successfully win the first order. So this is how Vitrox started. And this ex-intern is now one of our top management, Mr. Yoshi. So this is the birthplace of Vitrox, the humble beginning. Okay, why we say it's a humble beginning is actually because, sorry, we started at a rented bedroom at the point of time. We started at a rented bedroom instead of an office and so on. And this building still exists in Penang. It's this Sungai neighborhood. Okay, so this is our journey through our expansion right now. We started in 2000 and in 2001, before 2012, before 2018, we are actually located at Biopas. 2018, we actually fully moved to Batu Kawan, which is known as Campus 2.0. And we are having a new expansion as well, which is known as Campus 3.0. We'll be completing expansion soon by end of the year. And this will be for mainly focusing R&D, and we have a future expansion of university and college in upcoming years. As of now, we have about more than 1K employee all around the world, not only in Malaysia, also in China, Taiwan, Philippines, etc. What's our product? So, as I mentioned just now, our main technology we actually focusing on machine vision. So, what is machine vision? Machine vision basically is enable the automated visual inspections of semiconductor devices for quality and process control. So you can see that if let's say you only inspect on cosmetic defect. If let's say there's any scratches or missing lid, right, or rejected parts, then we will be actually take it out. Okay. So this is a simple illustration. I believe that Mr. Lau will explain in detail later on what is machine vision about. So basically we have camera and lens and then different light source. And after they capture the image process library and software, it will start to process. Okay, this is what basically machine vision is about. In details we'll share with you later on. So our vision system, right, you can actually measure into different industries that you can see on the slide itself other than semiconductor. Okay, this is beyond semiconductor and electronic assembly. There are few others areas that you can actually work on. So these are our solutions, okay, range of the semiconductors and few other areas as well. Okay, so this is a very pioneer product CPUs, vision inspection system designed for six-sided inspection of wide range of IC packages. And then we have motion vision handling and wafer vision handling. Wafer is not the one that can be that you can buy the sensor. industry waiver. And we have tray to tray vision handler that inspecting IC packages tray by tray. And tray to tape and reel, which is that can straight away reel with a one-stop solution kind of machines, which after you inspect, you can straight away take and reel. And we have PCB SMT that we have ASI machine. They're focusing on X-ray inspections, focusing on PCB inspections. And we have AOI inspection, that 3D optical inspections, and also solder-based inspection as well. And we have robotic machine inspection system. Again, these are the one, and also this one. Electronic communication system is one of our business unit that is focusing on design and manufacture its I/O card and motion card and also controller. Okay, um, this will be their products. You can see stepper motor controller, I/O solutions, motion system, and so on. And we have re-architect solutions that mainly, this is a very brand new team. I think we established in the year of 2020. It's about 2 to 3 years old for this brand new division. They are actually working on design, develops, and promotes those smart agriculture solutions. Importantly is to minimize the labor dependency, because for agriculture sector mainly they are actually focusing on, they use lots of foreign worker. Okay, when you go to Cameron Island for vacation, you get to see about that. So we try to minimize labor dependency and also reduce pesticide usage in farm and also improve the yield. So these are the solutions that um, provided by them that can improve the productivity. Okay, so other than that, we have the Industrial 4.0 Manufacturing Intelligence Solutions. It's actually a highly customized platform which offer data-driven decisions and so on. So you can see that you can gather the data using the one, and then you can visualize the pattern with V1, and you can do some analytics, decision and etc. So this is what we have for V1. Okay, this one is a bit repeating as well. Actually explaining. And PAC, People Automation Cluster, is basically our joint venture between Vitrox Corporation and our master and also local engineering. It's a one-stop metal component supply chain hub. Okay, we're also having a Vitrox Academy, Vitrox College, established in the year of 2020. Mainly, we're actually providing diploma courses in electronics, EE engineering, mechatronic engineering. This is our financial highlight. Okay, and our customer base. So for our HQ will be located at Penang, Malaysia. We have a small R&D lab at MNU Cyberjaya, but most of the headcount or internship opportunity will be in Malaysia, Penang. So we have some of the sales support office in other, for example, in China, Philippines, United States, Germany, etc. So this is our worldwide customer base. You can see most of our customers are overseas. Malaysia only about approximately 20%. So these are some of the globally known semiconductor customers that you can see, for example, Huawei, then for SMT, you can see like Tesla, Xiaomi, Oppo. So they are our customers. So achievements wise, we are actually awarded as a green building with a lot of green initiatives that actually we have work out all the time. And then we are awarded at first 3D Inline ASI system provider, world leading 3D Inline system provider as well. Okay, so skip. We have more than 700 worldwide installed base by products, and also more than 18 awards that we won in the past. Okay, and also we awarded as a 4-star ESG company. And just to mention that we have listed the 4th Asia Best 100 million for 6 times. Okay. We have CSR that we actually involved in educations. We hosted student visitations, involved in Penang International Science Fair. They're going to happen this weekend. Okay, we have a booth there to cultivate the STEM interest among youngsters. And we also done a lot of CSR activities to the community and charity event as well. What do we get from Vitrox? If let's say I've heard from uh, yeah, just now it actually mentions that most of you are actually from year three, right? Year three, right? You're looking for internship. If you to join us, you will see a conducive workplace, which is that we actually adapting open concept office. Okay, so this is our office. basically all of us sit like in this kind of setting, and this is manager sitting, which is no specific office that actually allocated to the manager. Okay, they also sit as this open concept office. Okay, this is our R&D office and manufacturing floor, and this is our workplace that we have auditorium, we cafe, they have coffee, cakes, tea and juice. We have library, cafeteria that we actually providing free lunch daily from Monday to Friday. So after works, we have some healthy lifestyle, the ongoing and yoga class. We have gym rooms, multi-purpose spot that can enjoy basketballs, sepak takraw, and etc. And we have festival celebration from time to time. We have interest club activities that happen in this year. You can see that we have basketball tournaments, we have Christmas cookie makings, etc. Or they can do this extra thing. Okay, we have overseas company trip. Let's say a company will be rewarding the employee if let's say we achieve a really exceptional goods result on that particular commercial year. So during my employment with Vitrox, right, I actually been to Eastern Europe, New Zealand, and also Croatia. This is the reason why this came back in April. Okay, April this year. Yeah. So this is special interest club they can join, get to know some peoples, and also unleash your potential talents like singing or maybe you're good in dancing and all those. So yeah, this is some industrial training program. For applications in 2024, it's now open up. So if let's say anyone of you are interested to apply for internship, you can submit to hr@vitrox.com. Okay, so I think yeah, there are some tips on for you guys on internship searching. So I would advise you guys to actually take a look on these tips lah. Okay, so if let's say you are still yet to design resumes, right, you can actually design a resume template. You can search at Google, refer to a senior, find a template, and then explore your passions that what you want to do. Let's say you want to focus on in IT, or you want to look at software development in AI, try to explore it, and you state it in the resume. After that, you write a good resume. Tell us what you like to do, what are you good at, mention about your projects, like for example, your funding project, capstone, IDP, etc. And state down your working experience and skills. If let's say it's not relevant, like part time, all can actually state it, no worries. And then extra corporate involvement, your achievements, like for example in academics, like for example dean list lah, best student lah, top achiever lah, all those you can actually state it. And if let's say you have any competition, you can state it as well. And reference. Okay, after you write your resume, check on your resume first. Grammar error, contact detail is it correct and all those things before submit any application. Okay, after that you can start to research on the company industry that you like to focus on. Then after you have actually decided, just send it out. So once you send your application out, please be ready that anytime you will receive a phone call from HR for a phone screening. So don't expect that people will call you maybe 2 or 3 weeks later. So every ever ready once you submitted, ever ready that people will call you. So you're gonna be ready and you do preparation accordingly. Okay, so I think roughly that's all at the moment from my end. I will be stopping here and I will pass the ball back to our speaker, Mr. Lau, to continue his technical sharing in machine vision. So I'll hand it over to you, please.
Okay, thank you, Mingli. Maybe before we start the session with Mr. Lau, I just wanted to ask regarding the phone screening just now, right? So is it like an interview sessions for the students, for select students?
Okay, phone screening basically is to gather some information regarding of the applicants. Let's say perhaps that the recruiters would like to understand further about his project. Maybe lah. Let's say the student A didn't include any projects in his resume. So only CGPA and those basic info, they're a bit hard compared to those other applicants that they have more details, uh, resume. So if I say that recruiter would like to give a chance, then they will give a course to this candidate A. They try to get more information and ask them to resubmit latest resume. so that it can actually increase the chance of being shortlisted. Or either it could be another situations that the information provided is not complete. Maybe they didn't say the CGPA. They only stated that bachelor degree in computer science from Unimas, but they didn't say the CGPA. There's a blank over there. So
Nice.
probably the recruiter would like to find out further info, then they will give them a call. So ever ready lah.
All right. So meaning
Yeah.
that once the students are shortlisted, and then there will be another interview sessions online, or how is it?
For intern, mostly online, virtual interview by using Google Meet.
Okay,
They will
so
meet
I
up
think
with the technical, technical department team leads.
all right. So yeah, I think most of the third year students now they are looking for internship placement. So yeah, we always promote Vitrox actually as one of the internship training placement lah. So for all of the students here, if you are interested to join Vitrox for the internship program, so you can always email to the that have been provided just now by Miss Ming Lee just now, right? And then you just wait for phone screening. Yeah, if there's any information that they need from you, and then later on, maybe if you are selected or shortlisted, and then they will do another interview sessions, right? Yeah. Okay.
Okay.
So yeah, thank you so much, Ming Lee. So every time I heard the stories of the founder is very inspiring, because what started as like a final year project, and then with the industry, and then it can started from that small humble beginnings. Now you have this very large company. So it's very always inspiring to hear that stories. Yeah. Okay. So uh, the next sessions is sessions with Mr. Lau. So maybe before we start, I just wanted to have a quick introductions about Mr. Lau Ziwei. So Mr. Lau Ziwei is actually have been working with Vitrox for almost 10 years, right? And currently is a senior research and development engineer in the Vitrox HQ Penang. So he graduated from Multimedia University, MMU, with a Bachelor of Information Technology in Software Engineering. And he has 3 years software development experience in Vitrox Research Center, or COE, and mostly involved in mobile app developments and software library development. And also 7 years of machine vision application experience in the Vitrox Tray Handler Machine Vision Business Unit. Okay? And he now specializes in 3D machine vision research development. Okay? So without further delay, so I would like to give a warm visual welcome to Mr. Lau Ziwei to share his knowledge and also experience in the research of the 3D machine vision. So, Mr. Lau?
Okay, thank you, Dr. Novatlan, and thanks Ming Lee too for inviting me. Okay, so you guys can hear me, right?
Yes, yes, we can
Yes,
hear you.
okay. Let me share my screen first. So can you guys see my screen?
Yes, we can see your screen.
Okay, good. Okay, so good afternoon, everyone. And my session, I think, just take about 1 hour plus. Okay, so but I hope my sharing will be a more interactive session. So if you guys have any questions, do ask me. Can ask by opening your mic, or you can ask by using the chat box. I see there's a chat box in the Webex, right? Yeah, so you guys can type your question there. And of course, I will also ask you guys questions from time to time to make sure you guys not fall asleep. Okay. So Yeah, inside the chat box. Okay, hope you guys see it. So I would like to do some quick survey before I start. Okay, so how many of you are from science stream background? So when you're in secondary school, how many of you are from science stream background? You can type 1 inside the chat box. Okay, good. Seems like a lot. Okay. Okay. So how about any one of you have learned computer vision or deep learning things before? Type 2 inside the chat box. Okay, so I suppose you guys haven't have no any knowledge about computer visions, machine visions, and also AI. Then it's okay. So my sharing today actually is to give you a brief overview of what machine vision looks like and its potential in uh, current world. Okay, so how it affects our current economy, our lifestyle, and how to actually design a simple machine vision system. Okay, so without further ado, let's start. Okay, so this slide is shared by Mindy, so I just skip. So my today contents very simple. What's the machine vision for the first part, and some application of machine visions, some real world example. My part two, and also a very brief introductions of machine vision components, okay, such as camera, lens, and lighting, uh, in the machine vision field. Okay. Okay. So first one. Another question for you all. What is machine vision system? Okay. Can anyone answer? You can type or you can open your mic. It's okay. You can just explain from your point of view. You don't need scared, it will be wrong. Okay. What is machine vision from your point of view? Anyone? No one? If no one, then I think I just randomly select from the chat box or the participant. Can? Okay, so who's the lucky one here? Oh, there are a lot of numbers, no? Okay, who is the what's the lucky number? Okay, let's pick 79826. Lolly Wun. Okay, Li Wun, are you there? Ah, yeah. Oh, you already typed the answer. Okay, use computer to automate industrial process. Half correct. Yeah, automation is one of the keyword. Any more? Any more? Or I pick another lucky lucky person. Hey, 79790. Tất Khải, are you there, Tất Khải? No. Okay. So how would you express machine visions in your point of view? Just now you have seen a lot of slides from Ming Li, right? From my colleagues. You should have some impressions. Yeah. Okay, you can just type. Just try. It's okay. It won't be wrong. A technology that enables computer to interpret and make decisions based on visual data. Yes, almost correct. Almost correct. Okay. So I think you guys have some basic understanding on how can it impact the world. Basically, it's in the automation world. Okay, in the automation world. So right, it's correct. We're using computer to automate, and also it's correct that we use computer. We write program in computer using some image processing algorithm to interpret and make decisions. Okay, but before that, we also need to make it has the ability to see. Okay, so in formal explanation, machine vision is the ability of a computer system to capture, the visual information, then perform analyze and feature extractions to extract useful information from the visual image. Okay, by using imaging hardware, by using motion control like robot arm, etc. And it's basically to provide imaging-based automatic inspection and analysis for various applications. Okay. Okay, very good. Let me continue to the next slide. Okay. Next question. What is this? This is apple, right? So how do you see it and recognize it as an apple? I think this should be an easy question for science stream student, right? By how it looks, shape, okay. The shape and the color, okay. Anyone else? Can you explain it from the physics point of view? Like the physics you learn in Form 4, Form 5? The maybe some optic or lighting physics? Anyone? Oh, I picked from the just now who say one. Okay. Next lucky one is Daniel Mew 79155. Okay. So how do you see it and recognize it as an apple? Just now, the few students before answered is how I recognize it as an apple, but they didn't answer how do we see it as an apple. So can you tell us how we see it as an apple? Daniel? Unique shape. This is recognized. How do we see it? Oh, we have a bingo answer here. An object in which its body reflects the red color light ray to the observer eyes. Correct. The keyword is the reflections. Okay, light reflections. So how we actually can see it is for light reflections. So Daniel answer is for recognize, while Nelson's answer is for see. Okay, so that when these two answers combine, it will become like how we perceive it as an apple. All right, good. So yeah, the human visions overview. So before we invent machine visions, we study our human visions. Then we try to copy the human vision's ability into visions. So what is actually the main concept of human vision? First one is the illuminations. Okay, so what you can see now around you actually is from light reflections. We have a light illuminate the object. Okay, then the object reflect the light into your eyes, pass through your pupil, cornea, lens, okay, all these bio things, and then focus at the retina here. Okay, and you actually become an inverted image. This is Form 4, Form 5 physics. Okay, you can go back to revise one. So it will form an image here, and it will send the signal to our brain. Okay, so this our brain receive this signal, then we recognize it is an apple. So that's very simple. Okay, very simple, right? Yeah. So can you think of any device similar to human vision? I think just now I already show you the answer. Okay, this is a camera. Okay, it's a camera. So camera actually is the invention of human by studying how human eyes work. Okay, so camera also used to capture the light, then store the lighting information in the digital format. Okay, so let us see how the camera and human eyes are same in their format. Okay, so camera has aperture. Okay, this aperture actually is similar to our eye's pupil. Our eye's pupil control the amount of light that enter our retina, right? When you go into a very dark place, our pupil will grow bigger. When you go under the sunlight, your pupil will automatically shrink into smaller hole. Okay, to limit the amount of light enter your eye and harm your eye. So the aperture actually do the same thing. Okay, it controls the amount of light enter the camera sensor. And we also have the lens here. Okay, so this lens actually is to focus the light that pass into the pupil, then focus it into the retina. Retina is our vision sensors on human body. Okay, it's our vision sensors. Well, this one is pass through the lens here. Okay, pass through the lens here, then focus onto the imaging sensor. Okay, imaging sensor here. Then after that, the imaging sensor will convert the informations into the PC or SD card for storage. While human is connected to brain. Okay, so you will see both camera and human eyes actually share a very similar working principles. Okay. Well, let's look at an example. Okay, example of machine vision in filming industry. So in these pictures, okay, what components can you guys see that you think are one of the components of a machine vision system? Please type your answer in the chat box. Hello? Should be very easy, right? Already in front of you, just need to complete the words. Come on, just try. Oh, I have to pick a random number. Green screen, actor, camera. Okay, correct. Any more? Any more? There are a few more. Oh, bingo. 533. I don't know your name. Yeah, it's the lighting. You see the above here, right? It's actually a illumination. They try to illuminate the actors. Okay. So we have the objects to be captured, which is the actors, like said by Nelson, and we have illuminations. Okay, set by 533. Okay, and we have cameras. Yeah, cameras to capture the actors, which is object to be captured. And then not forget, we have a processing unit here. Okay, processing unit here to preview the image. Then try to maybe replace the green screen with some real-time object. Okay, you guys all know what is the what's the usage of the green screen, right? Okay. And then we have a feedback system. Feedback system now is a human sitting here, okay, giving the feedback whether the image capture is okay or not, okay or not. So next you can see some example. Yeah, okay, this technology is widely used in the Marvel Studio filming industry. Okay, the green screen. So they try to use green screen because they want to have a very clear separation of object and background so that they can replace the background as they want. Okay, so this is the fun part and how machine vision actually can affect the entertainment and filming industry. Well, Vitrox is focused in manufacturing, machine vision and manufacturing. So we also have the same component in manufacturing line, just maybe not so beautiful and not so attractive as the filming industry. We have camera, we have illumination, which try to illuminate the object, and we have object to be captured. We have processing unit here. Inside the processing unit, there's a machine vision software, which utilize the image processing library, maybe OpenCV or Vitrox imaging library, etc., and perform some decision making. Okay, saying that this device is pass or fail, then it will send a signal to the feedback system. The feedback system in this case is actually a puller. Okay, it try to pull the object away from the conveyor belt if it deemed that the object is failed. So you can see here, right? The illumination is very important in manufacturing case because we need to light up the object so that we can see all the features that we want clearly, and of course we want to reduce the noise around the object. Okay. Next one is see. Okay, a very simple quiz. What are the hardwares involved in the machine vision system? Can you guys answer now? Just a recap. Okay, after I say so much just now, just a recap. Don't worry, it won't affect your final paper result. Okay. Okay, or I just pick a lucky boy again. Maybe Raphael Kong. Of course, no final paper. Okay. Okay, lens, image sensor, camera. All right. Processing unit. Yes, yes. Looks like you guys have listened to my talk carefully. Very good. Okay. Yeah, next is the activity. Okay. So this activity is to introduce to you how human act as a ultimate vision system. Your brain is actually a very good software in processing image. So let's say now you are trying to use your brain to sort this six image. Okay, how can you try to sort this six image into three groups? Like group A, which image? Group B, which image? Group C, which image? Anyone? Okay, it should be very easy, right? Easy IQ questions. How can you separate these six images into three groups? Number of each. Okay, very good. Any more? Okay. Yeah, you can say number of each. So H, okay, H, how actually you separate the image according to number of each? So group A is which image, group B is which image, and group C is which image? Can you tell us how you use number of edge to separate? Or anyone can help? Group A is 1, 5. Okay. Oh yeah, 1, 5, 3H. Okay. Group B, 2, 4. 2, 4, 4H. Group C, 3, 6. No H. Okay, correct. Bingo. So our brain is that sophisticated. You can get the answer in very short of time. Then next question is, one step before you recognize the H, what your brain will do? What your brain will do? Count? No. Recognize pattern. See the shape. Identify the shape. So the keyword actually is from answer of no I need, see. Okay. What our brain do, we see first. So how actually we see the object inside the image? Actually, we see the object. Okay. So our eye actually acquire the image first, as explained using the human vision model at previous slide. Okay. So by seeing this image, how can I tell there is an object? How can I tell there's an object in image 1? Let's say. How can I differentiate? Color contrast. Good. Okay, very good. Very close to the answer. So actually, we are trying to see by separate the object from the background. You have very big contrast between object and the background, right? So you can extract the object very easily before you actually try to recognize the object and try to analyze the object. Okay. Now, first thing here, have you guys noticed there's a small dot here? Can you see my mouse? Okay, small dot here and small dot at the image 4, small dot at the image 3. Can you guys see? So why you guys will see only the circle but not the small dot here? Why? The size is too small. Okay, very good. This is one of the reasons. Okay, but the main reason actually is our brain actually is automatically attracted to a more salient object. Salient is mean more eye-catching. Okay, what can actually explain eye-catching? Is the object is big enough, object is colorful, object is very contrast for the background. So our brain actually has the ability to remove the surrounding small noise so that you can focus on the object that you are interested to and you try to analyze it. Okay, so the important keyword here is the noise remover. Okay, so anyone here know the noise removal terms in computer science? Okay, computer science student. There's a term in for the noise remover. Anyone knows? Okay, perhaps you guys haven't studied the computer vision yet. Okay, it's okay. The answer actually is the denoising. Okay, I will type in the chat box. It's the denoising. Okay, so you can actually search the Google around for many of the denoising techniques in the image processing. There are a lot. Okay, a lot of techniques. which can help us to remove unwanted information so that we can get the result that we want only from the correct information. Okay. Well, just now, the first stage, the way we see, and then like answer from H, using color contrast to separate the object that we see and the background. There's a term also in computer science. Okay, anyone know what's the term? Okay, actually it is segmentation. Okay, segmentation. I'll retype inside the chat box. So segmentation is the term we use when we use image processing technique to separate the object of interest from the background. Okay, this is segmentation. And then just now there's a student says see the shape, see the edge. Okay, by using the edge. This one is the last stage. We call it feature extractions. Okay, feature extractions. So this feature extraction actually is we try to use further image processing technique, which is more complicated to extract the edge, or in the more advanced case, extract the number of corners. Okay, number of corners also can be used to interpret this text image, okay, beside the number of edge. Yeah, so this is how our brain actually perceive the image. This is very easy for our brain. But now we want to move it to the world of machine, or to the machine perspective. Then it will be very require many steps. Okay, so next slide will show you how our machines actually process the things that I showed you just now. So we see from the bottom, okay, bottom here. Just now we see this triangle because there is a light reflection, reflect on your PC screen, then it go into your eyes, go into your brain. But now, let's say I want to feed this into a computer system. I want to feed the computer system. So I will capture this image first. Well, light reflection actually is travel in the waveform. Light is in the waveform, so the signal is analog. The signal is analog. So there will be some image acquisition techniques, okay, which use camera, to capture the light wave, and then transfer it into the electrical signal. Okay. Then, by using the electrical signal, we try to do digitization. Digitization is we try to perform sampling, quantizing, and storing, and output it as a digital image. Let's say your phone's JPEG, your phone's HIF format image, or using this technique. Okay, so now I have an image. I will need to do pre-processing. Inside the pre-processing, like the image 3, 4 here, there will be some noise, right? For human, it's easily to be differentiated, but for computer, it's also considered an object. So I need to pre-process it. I will need to use some denoising algorithm, maybe some block size filtering, okay, to filter the small noise, small dot, so that it left only the big circle and also the square here. Okay, so this is pre-processing. So after the pre-processing, actually, then we will do some segmentation. Segmentation is where we segment out the object from the background, so that now computer only see the ellipse here, only see the red color square here. The computer doesn't know the axis of the white background. Okay, so this is segmentation. We segment out the object we want, then we try to extract the feature. We try to use algorithm to find the edge, of the square here. So it will return 4. Find the edge of the circle here, we return 0. Okay, so this is feature extraction. Then using the number of edge returned, we do decision making. Okay, we decide, oh, there's no edge, then this is circle. There's 4 edge, then this is square. Then if there is a 3 edge, this is triangle. Okay, so this is basically how complicated is the machine vision flow as compared to human eyes. Okay, but later on we will see how how machine vision actually can overcome human vision limitation and even help humans in this modern world. That's why machine vision system is very, very common now in every place. Okay. Okay, quiz 2. Just test your understanding. What's the function of image acquisition system? And what's the function of image processing? You can answer any one of these questions inside the chat box. Just test your understanding from my previous explanations. Anyone? I need to do the random pick again. Let us see who else. Erin Wong, 79332. Erin, so what's the function of image acquisition system? Can you tell me in the way you understand? It's okay to try, don't worry, I won't scold you. Because it's still new for every one of you, right? So I just want to test your understanding. To fit the image into the computer, to segment the object from background from the image. Okay, the answer actually is the first part, to fit the image in the computer. Okay, all right. Then the second answer is to segment the object from background to the image. Yeah, this is one of the function of the image processing. Okay, very good answer. Looks like you understand a little. That the generic answer, the general answer for the question actually is to extract the features that we want for analysis and decision making. This is the main function of the image processing. Segmentation is just one of the step to image processing. Okay, yeah, very good try. Next one. Okay, in this, okay, this slide is talk a little bit about deep learning. Okay, talk a little bit about deep learning. So you guys didn't study about deep learning, right? So I just explain, just straight explain. So this is our camera we use to capture the image. Then we try to pre-process the image. Then we do deep learning, and then we do post-processing. Okay, so basically, where does deep learning exist in machine vision? So deep learning exists in machine vision field when we cannot use traditional image processing methods to get the result that we want to make decision making. Okay, like in this case, we see there's a good unit and bad unit from the image. In the image processing field, maybe there's already limitations on the image processing algo such that we cannot have a perfect or very good algo to determine thousands of good and bad image efficiently. And there are many overkill or there are many underkill. That's where the deep learning system comes in. Okay, because it can work beyond the traditional image processing algorithms. So in our machine vision use case, before we start to use deep learning, we need to collect image. Okay, we need to collect maybe few hundred of good image, few hundred of bad image. And we need to label the image as good and bad. That's the pre-processing part. Okay. Meanwhile, we also need to give the system the crop ROI, the crop rectangle, so that it only process the region that we want, but not the full image. Okay. then we try to fit into the AI training system. So this training AI system actually is built of a deep neural network. So this is how the deep neural network looks like in illustrations. Okay, we fit the image inside, right? Every image has many pixels resolutions. Let's say your camera is 1000 times 1000 pixels, then you have 1 million pixels. Then this 1 million pixel data will be fit into the deep neural network as the input, and then going through some mathematical equations and create the output. You can imagine this as a y equal to mx plus c. Okay, so this is the x, this is the y, and this is the y equal to the mx plus c. So you can see that the things that we pass around here is actually the x and y, and then the next x actually is the last y. Okay, then the things that we cannot control here actually is the m and c constant inside the y equal to the mx plus c. Okay, then these two constants actually will be determined by the training engine itself when it train the image over and over again. Let's say I have a first training session with this few hundred image, and then it randomly assigns some m and c across the formula, and then it output the result. And I see there's some maybe 50% of accuracy for my training result. Like 50% of the past image is say failed, 50% of failed image is say pass. Okay, then I train again with the feedback result. I train again, go into the layer, then the engine will change the MNC again. It will change again and again. After a few hundred iterations, okay, few hundred or few thousands iterations, it will get a M and C constant, which it is confident enough to say, yeah, there's a 99% of the image inside my data. I didn't pass that, it will pass when I fit into the AI. Yeah, then until now, then we can use the deep learning model to actually decide perform the decision making in the machine vision system. Okay, so this is the simple theory of how actually deep learning works. Okay, of course, it requires a vast amount of data, and when data is limited, we can use some augmentation software to augment the data by ourselves, so that it can generate a few thousand more fake data. But the fake data actually look like the real-time effect, but it may be in different orientation or different size. Okay, so this can also help to improve our AI model. All right. So basically, this is how deep learning do. And deep learning application actually has been widely used in our machine vision system in every business unit. Like in my business unit, we use it for detect the cosmetic defect, and also to learn the optical character recognitions automatically. Okay. Then in others business unit, maybe they will use the deep learning method to learn the object on the image they want to inspect and automatically set up the setting for the user. So user don't need to set up by clicking the software one by one. The machine just see the image, then it can automatically learn all the setup by itself. This is how powerful the deep learning system are nowadays. Okay. Yeah. So next we will go to this one. Okay, this one is actually explain the importance of hardware system in machine visions, because in university normally when they offer image processing course, they will emphasize more on the digital image processing, or emphasize more on the vision part. So students won't have much time to play with hardware. But actually, in the real industry, many of the image processing algorithm can be simplified, and many of the work can be simplified with the change of hardware by itself only. Okay, like this case, you can see there's a two image here. This second image definitely is a good image, right, for you all, because I can see the object clearly. This one, I cannot see the object clearly. This image actually is captured by using front light image, where the lighting is come from 90 degree above the object, straight, then reflect back to the camera. This setup actually is when I place my lighting at 45 degree around the object. So the light actually strike the object at a 45 degree instead of like the first image here. Then you will see the effect actually is changed abruptly. Okay, it changed to a much good image with a very good foreground and background contrast. So you can see this is how powerful is the hardware setup is. By changing just one lighting angle, I didn't need to like write a very complicated image processing algorithm to just extract the cross. Okay, this one can easily segmented by normal threshold. This one I think you need to do a lot of more image enhancement, noise denoising, etc. Then I only can get the cross. Okay, so this is the importance of hardware system in our machine visions. The next example is polarizer. If you guys got play with camera, I mean DSLR camera, then you probably will know what the polarizer is. So this is a very reflective object under camera. So when the lighting strike on the object and back to camera, there will be some ghost reflection here. So there will be ghost reflection here. Then after I apply the polarizer, wow, you see the reflection all gone by just adding one piece of polarizer filter. It's a piece of filter only very thin, just in front of a camera lens. Then I won't see the reflection here anymore, and I can process the image easily. Okay, so this is the importance of using hardware system in machine visions before you go into the software parts. Yeah. And of course, we need to concern about our budget and so on. Not everything that is good that we can use. Okay, we need to concern on the budget. Some very good hardware may be very expensive. Okay, then we need to think another way to solve it. Okay. So until now, any questions on the floor? Let's check the chat and see. Okay, if you guys have any question, you can just prompt anytime. Okay, just prompt anytime. Okay, so this is very good for your understanding lah. So if you are interested to intern in Vitrox, yeah, if you know this basic knowledge, then it will be beneficial for your interview. I can show that. Okay. So what's the importance of image acquisition in the machine visions? Okay, so it will reduce unnecessary image processing stage. And of course, just like what I said just now, it will shorten the software development time. Use very simple algorithm, then settle. You don't need to write a complicated long software in order to cater the many noise. Okay, and of course, when your program is short, then it will speed up the inspection process, which is very critical in our machine vision machine. Okay, very critical in our machine because our machine is running on the semiconductor chips. Okay, running on semiconductor chips, and the chips production yield actually can up to 60 or 70,000 units per hour. Okay, so the speed required is extremely fast. Okay, you can even see with your eye very fast. So the algorithm should be very simple and fast. So, and now by reducing the noise, we also can improve the system accuracy. So you can recognize the object easily, and you can measure the object more accurately. Okay, and also can reduce the overall system cost and improve the consistency of the system. Yeah, consistency or repeatability is one of the other one. Beside accuracy, consistency is one of the important aspect also in our machine vision system. So if your machine is consistent, then no matter how many times you input the same object in your machine, and it will get the same result, okay, or near result, okay, very near result. And our machine vision system can go up to repeatability accuracy of 5 micron, okay, 5 micron perhaps. Or some machine actually, when we reach wafer inspection level, can up to nanometer accuracy and repeatability, okay. Okay, so I think I have said a lot. So by seeing this image, this is actually one of our machine vision module, system module. By seeing this image, I'll throw you a question now. How would you measure whether a machine vision system is good? And what is the criteria that make it a good choice? Let's say you are the customer, okay? Anyone can tell me from this image? How will we measure whether a machine vision design is good, or what is the criteria that make it a good system? What is the criteria? You just need to tell me what is the criteria you are looking at if you are a customer. Can you imagine that? Anyone? Accuracy. Okay, correct. Tashera. Okay. So you can see here there is a spec on the accuracy. 12.5 micrometer. Yeah, this is one of the things that customer always look into. Okay. So the more accurate you are, the less trouble they will have, because they will need to compare your machine result with their factory microscope. Okay, they will need to compare. So if the accuracy is higher, then they can close case earlier. Otherwise, you will need to modify your algorithms, etc., or your hardware to actually to fulfill the requirement of the customer. Okay. Okay, anything else? Grab time resolution. Yeah, it's a grab time, right? Not grab time. Yeah, I think it's typo. It's okay. So it's grab time. Yes, grab time and resolutions. So camera resolution. Resolution means what? Dinner? Okay. Okay, just joking. So camera resolution is also playing an important role in the choice. Okay, the higher the resolution, then you can get a better accuracy. But is it always the case where higher resolution is the best? The higher the better is it always the case? Anyone can answer these questions. Most important is the price. Yeah, the most important is the price. Yes, but the functionality is also important. Okay, so the camera resolution actually depends on what customer want to inspect. If customer only want to inspect have or don't have, present or not present, it doesn't need to so high resolution camera. Then we can also get the edge of the object or get the boundary of the object using a very low resolution camera. We also can do that. But if the customer want to measure a very very small crack, maybe up to 5 micron crack width, or want to catch the foreign material on the object, is it where it is below 10 micron. Now then we need to increase the camera resolutions. Okay, so we got many different vision system package offered to our customer. So see what they want to inspect, then we try to offer them the most cost effective. Okay, our aim is to offer the most cost effective vision solution to our customers. Okay, and just now Kai have mentioned grab time. Yeah, there's a grab time here. So grab time is impacted by the camera. Okay, your camera is higher frame rate, then it will have a shorter grab time. Okay, and then there's one cycle time. Under the grab time, there's one cycle time, right? You see. So this cycle time actually is time to inspect a unit. Time used to inspect a unit. Yeah, time used to inspect a unit. Okay, so science stream student, can you help me to calculate how many devices this system can inspect in 1 second? Should be very easy, right? Mathematics. If you work here, you need to know how to calculate also. And then they were asking you in terms of hours, but now I only ask you in terms of seconds. 1 second. How many units that you can inspect given this cycle time? Anyone? Oh, very accurate answer. How you get it? Okay, actually it's 1000 divided by 135. Okay, then you get this answer. So actually it's about 7 unit per second. That's per second, you see. So 1 hour you times, you can up to 10,000 or more. Okay. So the most important thing we look often is the camera resolution, accuracy, cycle time, and you can see the spec here is the things that we look into. And there's a one thing that I didn't include here, which is the repeatability. Okay, like I said just now, repeatability is very important. Okay, in our system, which is having very fast inspection speed. So you want to make sure that every unit that pass through our system have a very, very consistent result. Okay, otherwise it will fail or it will fail randomly. And this system is considered a very, very bad system. Okay. Okay, next will be, this is the information processing chain of a machine vision pipeline. Okay, so if you are very interested in the vision system, machine vision system, you maybe need to enrich yourself more in this field technology fields like optical engineering, okay, where you can learn to choose proper lighting, lens, camera, and then electrical engineering is where you try to connect the camera to the computer. Okay, but this one, if we buy from the vendors, then we don't need to care so much about this because we are not the one making the camera. Okay, but picking lens is quite important in the machine vision fields. Okay, and then last part, software engineering, of course. Okay, very related to you guys. So often related to computer, perform image analysis, then decides the output. Okay. Okay, observe the field image as shown to find the defect of the object. You see it? Okay. Can you see it? Cannot, right? Yeah. So just now you have seen how fast actually is the machine inspect our unit. But that one is the speed of my finger only. Okay, that one is the speed of my finger only. So you still cannot capture it, right? Yeah. So our machine speed is very fast, and you cannot even see with your bare eye. And then this is the speed of the machine. So why we encouraging production floor to use machine vision system instead of human visions? Okay. Any advantages or any human disadvantages? Can you guys share? You guys think of any? What is the advantages of machine vision system as compared to human? Or what is the disadvantages of human? Anyone? Reduce human error. Okay. Precision. Okay, same answer as Nelson. Any more? This one is related to the accuracy. Yeah. Because, okay, speed. Yeah, just now I very demonstrate that. can see the things that human eyes cannot see. Wow, this is a very, very advanced answer. Can I ask why you say such statement? It's okay to answer. I won't scold you. Okay, so your human eyes cannot see means nano size, means the size. Okay, very good. Okay, very good. Yeah, we can use lens that can zoom very big into the object and then check the defect that we cannot even see using our eyes. Yes, electronic now in nano size. Yeah, that is correct. Especially in the wafer chips war world. Okay. Anything else? Yes, that's me in review the answers. There's some of my answers. First one is increase productivity. Okay. One machine can beat 1,000 humans. Okay. One machine can inspect like almost 100,000 of object per hour. You compare that to humans, how many humans you need to inspect 100,000 objects? Okay, and then extend the capability of human vision. Okay, like just one 533 say, see the things that human cannot see. And his answer is in terms of size. I have another answers. Okay, because in machine vision system we can use lighting, and the lighting there lighting is made up of a wavelength, and there are many different wavelengths beside human visible wavelength. Human visible wavelength means the color of the rainbow. Okay, you can see color of the rainbow from red to violet. There's a color that we can see using our eye. But there are some lighting that we cannot see using our our eyes, such as infrared, ultraviolet, X-ray. I think ultraviolet can see. It's the X-ray and the infrared. So by using this lighting on certain object, you can actually extract some very special features that human eye can see. Okay, like we use the infrared actually to penetrate into the small die, the electronic die. Okay, sometimes the electronic die is already packaged, but inside the die there is still many electronic circuits, and we want to check whether the electronic circuits inside has inner crack. So by using the color visible light, we cannot see through, right? So we need to use the infrared so that we can see through the die. Okay, we can see through the die. Then we can see the inner crack from the infrared. And some will also use X-ray. And actually in Vitrox, there's a X-ray inspection machine. Okay, they use X-ray actually to penetrate through the very thick SMT PCB board. Okay, layer by layer, slice it into layer by layer, then perform inspections. Okay. The next one is the reliability and consistency. Yeah, this one already talked just now. Reduce the cost. Yeah, because nowadays the labor cost actually getting more and more expensive following the inflation. Although machine price also go up, but the overall price, overall cost actually is much more lesser than to employ a labor, because human labor have many uncertainties. Sometimes they injured, sometimes they claim insurance, sometimes they take sick leave, and a lot of excuse. Okay, that's why using machine, it can work for you 24/7, non-stop. Okay, and then ease of data collection and analysis. For human, well, when we collect data, we need to record slowly into the Microsoft Excel, then we use Excel to plot graph, etc. But now by using machine, everything becomes very fast. After you inspect the data, straight pump into the hard disk, and then you can use some visualizer software to analyze the software afterwards. Don't need the copy and paste. Okay, and then machine have a flexible working environment. some of the machine vision they require in a very tough environment, like very hot environment or very cold environment. This is where the human actually cannot working on. So we need to depend on the machine visions. Okay. So just now we have gone through the machine vision model, human vision, machine vision, basic components, and why we use machine vision. So now come the interesting part, okay, the application of machine vision. So today, Vitrox actually is a machine vision company, but we only mostly we specialize in the semiconductor field and also some agriculture field. Okay, but there are still many more industry that actually machine vision can tap into. Okay, the first one. Okay, yeah. Okay, sorry. I will explain the main type of application first before I go into other type of industry application. So machine vision application, okay, mainly used for measurement. Okay, the first one is measurement. This is what we basically do. Okay, in our inspection system, we measure the size of the object, whether it passed the spec set by the customer. Is it bigger? Is it smaller? And passed by how much? Okay, like is it bigger than 50 micron and smaller than 50 micron? Some customer they set the tolerance of plus minus 50. Then if within the plus minus 50, then we say it's passed. Okay. Next is the inspect the presence. Okay, inspect the presence and inspect the appearance, whether there's some surface defect or foreign particle on the surface. Present is the quantity. We count how much water is here. Okay, whether is it missing. Okay, this is inspect. The third one is the position alignment. This is mainly used in robotic applications where we use machine vision to pinpoint the object that we want to capture. Then we use the robot arm. We command the robot arm actually go to the object and pick up the object. Okay, this is positioning alignment. And mostly it will use some image processing technique called geometry pattern matching. Okay, geometry pattern matching. Can type in the chat box here. If you are interested, you can go search around. Okay, geometry pattern matching. Okay. Okay, next one is the recognition. Yes, we recognize the QR code, recognize the barcode, recognize the OCR. Okay, so these are four main functions of machine vision application, actually being used in almost every industry. Okay. Okay, so this is one of our vision module specification. So this specify what actually our vision system can measure. Yeah. So there will be length, width, span, standoff, etc. Okay, where we can actually design the algorithm, to measure the dimensions. Okay, so there's some interesting question here. Do you guys think that AI can use to perform dimension measurement? Just how I say we use AI to detect the defect, determine the unit is pass or good. But whether can it be used to measure dimensions? Yeah, Nelson say can. Anyone say no? No one? So everybody say can, right? Can bar, okay. Partially correct. Okay. Yeah, we can determine the dimension by using AI, but it won't be as accurate as you using image processing algorithm to measure it point to point. AI is only estimation. Okay, it cannot give you the most most accurate point-to-point result. And in terms of our machine vision measurement, we are going into the accuracy of subpixel. Okay, subpixel. Let me type. Okay, subpixel. So this subpixels concept means that our measurement value can go up to point something something accuracy. That means image have many pixels, right? From pixel 1 to pixel 10. Let's say from 1 to 10, there's a 10 pixel distance. But our machine vision system, if using correct image processing algorithm like edge detection or what, we can actually get the very accurate value like 10 point something or 9 point something. Yeah, this is where the AI cannot do. So for our machine vision system in Vitrox, mostly our measurement is still performed by using the traditional image processing algorithm. Just that we maybe use AI to detect the surface defect or to do the noise removal. Okay, before we try to calculate the subpixel measurement of the dimension. Okay, so hope you all can get it. Okay, present inspection. Yeah, this is one example. Present inspection, like what I say, we inspect whether the surface has surface defect, has void, this is what we call void, has scratch, yeah, or there's a burr, or there's a foreign chipping, yeah, chipping here. Okay, there's a chipping here. This is a present inspection, and this inspection we do mostly in AI. Although traditional image processing, we can also be used to do it, but the effect may be not as good as AI. Or sometimes AI have been used as an assistant of the traditional image processing algorithm. Let's say I have a unit here. I fail the unit, but actually I can pass the unit again to the AI module to ask, hey, is it this really fail? Is it this really fail? Or the AI, after use AI inspection, it say, no fail. Then I consider it as pass. So we call this AI retest. Oftenly, we will use AI system to retest on top of our traditional image processing algorithms. This action actually is to improve the yield. Okay, yield. Can start here. Yield. Okay, the yield of our machine, which is also the throughput. The yield means the good unit inspection, because mostly customer will expect 98 to 99% of yield from our machine. Means we cannot overkill too much. If we overkill too much, the yield of their production fall, then they will be in trouble. So they need to control their production in 99% yield and above. So we use this AI retest function actually to help them improve their yield. If our traditional image processing algorithm actually overkill a lot. Okay, this is what currently we use to positioning alignment. Okay, it's very easy. Optical character recognition. Yeah, just read the barcode. And mostly there are a lot of barcode library and QR code library, so OCR library. But in Vitro, we have a AI OCR system. That means we use AI to learn a lot of different character pattern, because not all printing on the object is the same font. Okay, maybe of different font, or maybe got some Chinese word or got some pictures. Yeah, we can use the AI to learn that. Okay, what are the four main type of machine vision application? Quick check on your understanding again. Anyone? That's why I've said a lot. Maybe you all can get. Should be very easy, right? This one. Oh, you already fall asleep because my sharing is too boring. Yeah, measurement presence. Okay, very good, Nelson. Okay, the other two, inspect. Yeah, inspect. Position. Yes, correct. Can recall correctly. Very, very good. Okay, looks like you all didn't fall asleep. Okay, very nice. Yeah, now the interesting part, industrial application. I would like to talk about this part. Okay, automotive. Nowadays, a lot of self-driving car, right? Like Tesla, BYD, Xiaomi. Okay. So this self-driving car actually they also use machine vision. Okay. Like in this case, like in the Tesla, there are actually around 8 to 9 cameras, if not mistaken, put around their cars, then try to do surrounding image environment mapping. They try to stitch all the image together, then try to do environment mapping to map how their environment look like. At the same time, they do recognition. They recognize whether this is human, this is pedestrian, or this is the one human bicycling, or what is there a car or is there a truck at the blind spot there? You also can inspect. If it see only a little, you also can estimate and predict. And you can also check on the sign, okay, the traffic sign, okay, so that you can perform necessary driving decision when you encounter these factors. Okay, so self-driving car is hot, and now there is also self-driving truck. Although I think it's not seen yet in Malaysia, but I think in Korea or in Germany, this is already a norm. Okay, where there is no lorry driver, there's only a self-driving truck carry cargo, and then they are actually use this self-driving truck on highway. Yeah, because highway environment is more predictable, more straight roads. The road sign is also clear. Yeah, so it's very safe to use on highway, but maybe not in city lah. So maybe they will set a stop station at place near the highway or some things. Okay, to get a cargo. This is automotive industry. Okay, so self-driving car is just a start. Self-driving truck coming in, and maybe even in future there's a self-flying aeroplane. Not sure you dare to sit or not. Okay. Yeah, this one also very hot topic recently. Do you guys know what is this? Or what is this? Anyone know? Somebody should be very interested in space or astronomy, right? From this around, I think 27 students. James Webb Telescope, yeah, correct. Okay, James Webb Telescope. So in the astronomy industry, okay, James Webb Telescope can use their advanced infrared imaging system to study the beginning of the universe a few billion light years away, and also can help to find some habitable exoplanets. Yeah, and this one is a Mars rover, and this is the image that Mars rover sent back. Okay, so we can see that Mars rover or the Mars rover itself actually have a few combination of cameras. This image is captured using panorama cameras. Okay, where it capture panoramic image, then do image stitching algorithm to stitch the image all together to form a bigger 360 view. Okay, or bird eye view. So this image actually is showing the Mars rover using their chemical camera. We call this chemical camera because it try to shine a light at the rock here, and then some light will be reflected back, right? And then there is a chemical composition sensor, or we call spectrograph of some things. Yeah, we can analyze the chemical composition of the rock here. Okay, so you can see how advanced is the machine vision industry. Next one is sure. Okay. Anyone been to China before? Yeah, I've been to China once and I'm really terrified. Tell you, I'm really terrified. Okay, there are CCTV everywhere, just like this. This is only a small place. I see the one with like 30 or 60 CCTV on the bar here at the highway. Wow, this is crazy. Okay, so China have heavily used the machine vision in surveillance industry. Okay, so they will use it for vehicle speed trap. Yeah, this is an example of the China machine vision system, how they recognize. So you can see from the surveillance system, you can recognize, wow, this car is, what is the color or what is the type of this car, or even the car number plate. And human here even can identify this is a girl and this is an adult, and what is wearing is wearing a skirt. Okay, yeah, you also can identify. So why they are doing this? Okay, so because they have a lot of people, there are a lot of car, they everything of them is a lot. Okay, so they need a very good system to actually control or not control. I think it's to monitor their people, so that to lower the accident rate or to lower the crime surveillance. Okay, yeah, the crime surveillance in China is also one of the most effective surveillance system in the world. So in case I go to China and I stole something, okay, after 5 minutes, I will be captured, even though no matter where I run to, within 5 minutes I will be captured by police because there are CCTV anywhere. And from the time I enter the airport, I enter their immigration check, they already have my face image. They capture my face image. And then if I really do something wrong there, well, they can use facial recognition system in every of their CCTV here to find where am I, at which location, at which time, so the police can come and catch me. Yeah, there's a lot of introduction in YouTube. If you are very interested to see, you can go to YouTube and search. Yeah, it's really interesting. I go there once to support customer. Really terrified. If someone exceeds speed and captured by camera, the number plate and the image will be shown on the signboard beside the road here. Which car had been fined, had been summoned. Okay, the summon had been directly summoned from his e-wallet or what. So he only go to the uh, traffic department and pay the summon straight away, deducted from his account. Okay, this is a surveillance industry. Okay. Military. So military industry is a two example. One is the military drone, and the other is this is DARPA robot, DARPA. If you are interested to know, DARPA robot. It's DARPA robot. So military drone normally used for search and rescue purpose, where the camera here normally is a thermal imaging camera. They can fly to the hostage place and then check how many people are inside the house, so that they can think of a strategy on how to rescue the hostage. And this DARPA robot actually is very good in carry heavy gears. Okay, they can carry some guns or what heavy things when travel through the harsh terrain. Okay, because they are military, when they're having war, they're actually walking on very harsh terrain, not the road like our normal road here. They will need to climb through mountains, rocks, go through the river and all that. So this robot has been built to be intelligently, okay, can travel through this harsh terrain. Can see how many sensors are there in front. Okay. Okay, next one, warehousing. So warehousing, there will be AGV. Yeah, this one is the AGV, where you can automatically carry the product to specific location. And then this is the barcode scanner, automatic barcode scanner. Yeah, so actually, like in the Alibaba warehousing industry, you can see all these things moving around and few people inside. All are robots. Okay, if you're interested, you can go YouTube and search for the Alibaba warehousing. Yeah, it's a very intelligent. Okay, next is the healthcare. So the most prominent one is the body temperature checker. It's a very used widely when it is COVID time. So inside the hospital, this image processing technique actually can help doctor to identify the small tumor or small defect of a human organ. Yeah, by using image processing algorithm. Okay, next is agriculture. Agriculture, machine vision in agriculture is being used for fruit sorting. Yeah, fruit sorting, when some fruit has bruises or what, it will be rejected. Normally, we'll use infrared to sort the fruit because when you shine the infrared at the fruits, the fruit with the bruises will have a darker region. Okay. Next one is the aerial mapping. This one is drone. Yeah, you will map the whole area of your agriculture crop land. Okay, and monitor your crops. This one is to measure the dimension of your crops. Okay, measure the dimension of your crops. It's a cabbage. And this one is to, I think it's measure chicken skin. I'm not sure about that. Okay. Okay, next, consumer. Yeah, the most we use is touch and go e-wallet QR code. And then if you go to certain mall or certain airport, you will notice their car park system have been changed with this vision camera system. So you don't need to press ticket anymore. You just scan your car plate. Okay, you just scan your car plate. Then when you want to pay money, you just key in your car plate. That's all, pay, then go out. You will scan your car plate again and then let you go out. This one is the Google Lens. I believe you all have used it before, right? It's a free software from Google. I've used it a lot when I travel to foreign country like Japan, Korea. Okay, it really helped. Okay, I capture the image here. It can automatically translate the things for me. Okay, in English. Very, very convenient. Okay, next one. This one I think everyone's very familiar too, right? Snapchat. Use the vision applications to make fun. Okay, this actually is a 3D reconstruction image. You see the image is being moved at different angle. Okay, 3D reconstruction image along with 3D effect. Yeah, see how advanced the algorithm is. It can accurately pinpoint your face feature. Yeah, in the facial recognition system, it actually find where's your face first, then it will try to locate where's your eyes, where's your nose, where's your mouth. They will apply those effects on it. Okay, this is some sort of consumer machine vision application where the machine actually is a very, very small machine. Okay, very, very small machine. Okay, factory automation. Back to our world. Okay, factory automation is where Vitrox get in. Yeah, we will use it to inspect food and beverage. And then in our case, in Vitrox, we use it to inspect semiconductor chips. Yeah, this is NVIDIA chips. Okay, and this is the wafer. Yeah, we use a microscopic lens to inspect the wafer. And the lighting you see is come from the lens itself. This is one kind of a lighting system where the lighting can come through from the 90-degree of angle here, then reflect down. And then the image reflector will be go up here, go up again to the camera sensor. Okay. So the machine vision system actually can appear in many industry and many manufacturing line that you can think of. As long as you are manufacturing something, you should have quality control. You need to inspect the quality of the product. So that's where the machine vision kicks in. Okay, so it actually has a very huge market and yet to tap in, I think, in Malaysia. Okay, because many small medium enterprise SME is still using labor to check their things. Okay, so you have gone through the application. Now we go to the introduction of machine vision components. Yeah, very easy this one. Camera, illumination, object, CPU, feedback. I will talk few about the camera and lightings. Okay, so camera is a device that record visual image in the photographic form of video signal. Okay, I'm really very thirsty. So I have one question for you. This is a consumer camera. This is industrial camera, the camera that we use in our machine vision system. Can you tell me why we use industry camera? We are not using consumer camera. Okay, anyone? Different of light output. Okay, maybe you are saying about the sensor sensitivity, output infra. Okay, I think even your smartphone can capture infra, just that they add a filter. Yeah, if you remove the filter in your smartphone, then you can get the infra image. Robustness and reliability. Yes, one of the keywords. Anyone can guess some more? Can see the shape so different, why so different? Size. All right. Yeah, it's one of the consideration. But nowadays, the consumer camera is not that bulky anymore, especially you are using mirrorless camera. Okay. Okay, let me explain. So you see the industrial camera here, yeah, it's using metal casing. This is only hard plastic. So why they use metal casing? Okay, it's because they want to have better heat dissipation. Yeah, because industry camera we will use, will open, will capture, will live for 24/7, non-stop until the day die. Okay, that's the ideal case. So metal casing is important for the camera to dissipate the heat. Okay, so the one, yeah, Wen Qingyong has said the way the camera process image. Yeah, there is some smart industrial camera where it's smart enough to have a CPU inside. That's considered a correct answer also, because consumer camera I think don't have such capability yet. Okay. Okay, beside the metal casing I said just now, industrial camera mostly are mono camera. Okay, mono camera means it only capture and output the image in black and white. So why we capture in black and white? Because mono camera has higher resolution than color camera. Okay, this one you will need to know the concept of color camera and mono camera. Color camera inside the sensor, there will be RGB to form one pixel. But actually it consists of 4 pixels already. Okay, but mono camera, every pixel is a unique pixel. So it can have more resolution. And for our vision system, measurement system, we all prefer mono industry camera. Okay. Oh, such has a telephoto lens. Okay, that's the lens topic. We're still at the camera. Good try. Oh, you know about telephoto lens. That's good. Looks like you're a photography amateur, is it? Okay. And then industrial camera have a higher frame rate and it is more robust an environmental proof. Yeah, like say you can work in very harsh environment. This one, if you go winter area, if your camera is not weatherproof, then it will become GG. Okay. Okay. The function of camera, lens, and lighting. I'll explain very simple in the one slide. So camera sensor size, sensor resolution. Okay. High sensor resolution, low sensor resolution, you can see the difference. So like I said just now, higher sensor resolution is not necessarily the best, because some customer, they only want to know, is there exists a flower here? I don't want to know like how many petals are here. I only want is there flower. So I use low resolution camera to inspect, and it's okay. Okay, so this is resolution. So for this one, yeah, this will be related to the telephoto lens that H mentioned. So this effect is this effect is happen if you change different camera lens. Now this is the lens focal length. You play with the lens and you know this is a lens focal length. So if I use the larger focal length lens, I will zoom into the flower, like the H said, telephoto lens. So telephoto lens is a large lens, focal length lens. Okay, if I use a 35 lens, okay, I will pan outside. Okay, so I will see the bigger field of view. Okay, so now back to the machine vision. In machine vision, when we're choosing lens, we are actually based on what factor? It's based on field of view that we want. Okay, I type here, field of view. Okay, field of view is FOV. Yeah, this is a keyword. If you use it in your interview, you sure pass. Okay. So camera lens will affect the field of view. Field of view is how large of the world that we want to see. Okay, because some user, they want to see the very fine detail, then we will use a zoom lens, zoom into the object, and extract the feature, calculate the features. Otherwise, we just use bigger FOV. Bigger field of view means we can check more units at one time. Yeah, you see, it's a flower that's small, right? I can check like 10 or 20 flower here. I can have 10 or 20 flower here. But inside this 200 I only can check one flower. Yeah, this is the difference. And then in terms of lighting, the most important lighting concept is the hard light or soft light, or we call diffuse light or direct light. Direct light means your lighting straight hit the object and will cast a shadow. Diffuse light means the light will pass through a diffuser. You can imagine just like a cloudy day when the cloud block the sun, or you suddenly see every scenery becomes so beautiful and becomes so soothing. Yeah, that's the effect of soft light. Okay. And then just like what I say, the machine vision extend human vision capability. Yeah, this is the light spectrum. We human eye only see such narrow light spectrum. There are a lot of light that we cannot perceive with our eyes. But using correct sensor, we actually can get the data. Yeah, so the machine vision field actually is very wide, and there are many use cases. Okay. So how does a digital camera work? Okay, so it's just like collect the light wave. I think I just show you the next slide. Yeah, this is the light. The light have photons. Photons then fall into the pixel bucket here. Then it will be collected. After it been collected, it will be translated into the digital value. So this digital value, normal case, we will use 0 to 255, which is 2 to the power of 8. So there will be 256 different of bright lighting intensity value inside an image. Okay, so this can see. So this is where we perform digitizations. We try to sampling the process, we try to quantize the process and store the process into a digital image. Sampling is the resolution. Okay, we try to sample the light wave into how much resolution. The more resolution, the more detail. Okay, quantize it. We try to quantize the light intensity into digital value, and the digital value range, if larger, then can have more details. Okay. So this is the effect after we doing image capturing. This is the object in the real world. You see, wow, the edge is so smooth. So what? After you capture using camera, after perform sampling and quantization, it become like this. If you zoom into your image, you will see the effect like this. Okay. This is a low resolution. If you have higher resolution or higher sampling camera, you can have a more nearer effect to the actual object. Okay. Okay, this is a quantization level. I straight use this slide to explain. So quantization level, normally we have 256 gray value. Okay, so we call this the 8-bit grayscale image. That's why we are working on the, just now I say we are working on mono image because we have better accuracy and better resolution, right? So, yeah, we have 8-bit grayscale here. Then you can see the different effect. If you have more grayscale, you have smoother transition. Okay, and then the camera bit depth which is a quantization level. We call it bit depth in our image processing terms. Okay, the more bit depth we have, the more possibility of light intensity that we can express. But normally in image processing, if you want to display the image, it's only up to 256 because our display monitor and our display system can only display information up to 256. So this 4096 level, normally we use it for floating point image processing or high dynamic range image processing. Okay. Okay, so this is a simple example of quantization level. We come from this 2 gray level first. Inside this 2 gray level, I can only see a skull, a head skull. I don't even know it's a skull actually. Okay, but after I increase the gray level by level until 8-bit, wow, you see I can see much more detail. You can see much more detail here. I can see the spine here. I can see the vertebra here and some hypothalamus here, I think. So this is the effect of higher bit depth. Okay, higher bit depth. Okay, very nice. Oh, I think I'm over time a bit. It's okay. I think, yeah, this is my last slide on the introduction to machine vision. Yeah, it's very simple, and I hope you guys have digest few keywords. Okay, machine vision keywords which is useful in your future careers if you want to pursue career with us. But this is not my last slide yet, okay, because I have another mission. Because I heard your lecturer request how software measuring student can actually work with Vitrox, because machine vision is such a niche domain. It's such a small domain. Okay, very niche domain, not exist in many universities. So what the software engineering student can do? I am from software engineering major also. Yeah, I have been working at Vitrox for almost 10 years. So there's definitely a lot of things that we can do. Okay. So Vitrox is a total solution provider from back-end, PCB. PCM is the ECS. Okay, ECS. Then to the Industry 4.0 intelligent solution. Okay, so you may be wonder, so is it this one that I said is suitable for you all? No, because I'm vision engineer also. Okay, there's a lot of things that we can do. Yeah, software career, vision application engineer, like myself, machine motion control engineer, machine platform developer, AI developer, full stack developer, this is web developer, firmware programmer, software tester. Yeah, I will explain one by one. Okay, based on my experience. Wow, you see this vision application engineer, this is our three core founder. They are also doing their job as vision engineer when they start up Vitrox, and after that slowly grow the company to billion capital market. Okay, so what does vision engineer do? Design vision system. Yeah, we need to choose proper lens, proper camera sensor, and proper lighting to fulfill customer needs. And we need to develop vision inspection module. You can capture this slide if you want. Okay, and we also need to design the soft image processing algorithm. Yeah, because in order to get that measurement or get that defect, we will need to design algorithm. And then software optimization, yeah, this is very important too, because as I said, the speed of the machine is very, very important. So after you design algorithm, you think that's finished? No. You need to review your software again and again for more optimized speed, so that customer will be more happy. Okay. Next one is imaging hardware integration. Yeah, we need to write codes to integrate camera, integrate projector, any imaging hardware that can imagine, then we need to write code to integrate into our main software. And then we need to learn how to integrate third-party software library, like third-party image processing library. Yeah, for our case, we are using Vitrox imaging library. I can just share to you all. Vitrox imaging library. This is a proprietary library. And some of, I think we also use OpenCV for case study also. Okay. Yeah. And then in my career, okay, we use C++. Okay, some business units use mostly C++ as my business unit. Some business units, they use C# or Java as their front end because UI is not so low level machine things. So they will use C# or Java for cleaner code. And back end, they mostly will use C++. Back end is the algorithm things and the things that connect the underlying hardware. Python, you need to learn some Python for fast prototyping. Yeah. And you require extra knowledge on optics, image processing, like I said just now. This is the vision application engineer. Okay, next one, machine motion control engineer. Yeah, this is the one develop program to control machine from start to finish, every motion. Coordinate motor movement sensors according to machine. So you see this machine is my business unit machine. You see how complicated the machine is. There are a lot, I think hundreds of sensors and tens of motor inside the machine. You need to coordinate, you need to write code, okay? Write code to coordinate the motor movement. And then you use extensive multi-threading and event handling. Yeah, if you are a computer science student and you are very, very optimizing minded, you have an optimization mind, then you are very suitable to do this job. Okay, because you play a lot with the software design pattern, play a lot with complexity problem, multi-threading, event handling, and mostly we are using C or C++ because we are handling with very low level stuff. Okay, so some product may use the PLC. PLC is a programmable logic controller or robot OS programming. Okay, so require extra knowledge on E&E and mechanical because you are working with a mechanical engineer. Yeah, this is the motion control engineer. Of course, this is my senior manager now. Okay. Yeah, this one is playing with the hardware. Okay. Next is a machine platform developer. Yeah. So machine is very complicated. We have a developer that develop machine man software, which is a controller for all machine function, like the vision module, like the motion control module, all will be controlled by this man software. Okay, and it acts as the main window to user. So this person will try to synchronize the whole machine vision inspection process and try to adapt our software to customer production process control. because customer has their own production process. So we will need to, sometimes we need to customize for them, or sometimes we need to think of a better strategy so that we can tackle their problem. And this platform developer also need to know about machine interconnectivity control. Means our machine, in the production floor, there are maybe more than one machine, okay, more than one of our Vitrox machine. So machine need to talk to machine to share the setup setting, how to share some image data. So this person will do these features. And then after we run the production, we'll have data logging, data visualization. But this stage, we are still in maybe in text format, report, PDF, or HTML. Okay. And mostly we are using C++, Java, C#, Python, or web language. And we require extra knowledge on HMI or networking. Yeah, because you need to understand the networking protocol in order to talk to different machine, or it's either Vitrox machine or others companies machine. Okay. Next one, AI developer. Yeah, our AI developer normally is doing deep learning. So they are currently develop training and inference software. Training is where we train the data. Inference is where we use the mathematical model to decide whether the image is pass or fail. So they are doing this software to classify image, segment image, to detect object. Okay. And then they will need to optimize software to speed up process of data labeling. Yeah. Because some customer, they think that your data labeling is very, very clumsy, very, very slow. Yeah, so they need to do some automation for customer. Okay, and also model training and model inference. Develop data augmentation software that I said just now. If data is not enough, then we need to create fake data for the machine learning to learn. And then we research on the algorithm and improvement for the higher model performance, loading, speed, accuracy. And also develop customized model for some very tricky tasks. Okay. So normally we use Python, C++, or R in this case. And we have AI developer in Vitrox COE, which is research center. We also have AI developer in our business unit department. So they will actually work together, okay, to make sure that the AI things work properly. Okay, next is the full stack developer. This one is a developer that developed V1. I'm not sure you know about V1 or not. This is a screenshot of the V1. It's actually one of our Vitrox product, which is a digital dashboard. We call it the dashboard, where it can actually gain data from our machine or from any sensors or what, like IoT things. Then it display the data in the beautiful charting or summarize the data. Yeah. So this one is where the web developer is needed, okay, because it will develop both the front end and the back end. Back end is the database things, I think, and need to manage the database, yeah, and develop web app or service, okay, for intercompany process. Intercompany maybe is like company MIS, yeah, because in our company we also have production floor, we produce machine, we also have parts tracking, we need to track the parts. So all of these need digitalizations. Previously we all use manual, okay, so now we have this web developer, then they will create a very good web interface or a visualization dashboard for the not even the customer usage, it even used for our intercompany colleague. Okay, so you need to have some knowledge of web language. Okay, firmware programmer, this is for the VIE department. It's a department with an ECS solution. You develop software driver for embedded system, data communication controller, motion controller, and mostly use C or C++, and require extra knowledge of E and E because you are playing with the electronic circuits. Okay. Okay, last one. This is also the most important role. Software tester. Everyone think tester is not important, maybe a boring job, but no, not the case. Okay, because software tester has very big responsibility in software quality control. Yeah. So they will create and automate the test case. They will ensure the proper software suite release. Yeah, you see, we have many functions in our machine. We have vision, we have motion controller, we have platform, then we have V1. When everything packs together and need to send to customer, tester is the one that makes sure that all these software bundles is properly test and bug free before release to customer. So it is very, very high responsibility. Okay. And then we need to ensure proper software suite release. Yeah, this just now. And then we need to prepare the report. Yeah, after they test, after they perform the testing, they need to prepare the report or visualize the data on bug tracking or software release tracking. They need to visualize for the developer. Yeah, you need to go back to the developer, say, yeah, you have all these bug detectors, and then you add this feature, how many bugs you create by adding this feature. Yeah, he will tell you. Okay, so that you become more productive or you become more mindful when you try to write your software by not creating so much bug. Okay, and then we so develop software to automate developer software development life cycle. Because like I said just now, we need to bundle the software, right? Okay, we even need to bundle the software for production line. Okay, so this is where the tester come in also. It will bundle the software with correct version, because not all customer buying machine are new customer. Some are old customer. Our customer has older software and they don't want to change the software to newer version because it will sometimes break their process. Then we need to keep track. And then next time they buy the machine, maybe after 2 or 3 years, yeah, then we need to automate the system to pump only the old version for the customer. Okay. And then we need to interact with different machine function team. Yeah, because it tested a lot of different modules, the tester need to interact with different machine function teams to understand how their module functions so that they can create more specific functional test case. Sometimes they also perform monkey test. This is before they understand the function. They perform a monkey test. Then mostly they will capture a lot of bug there. Okay. And then we will participate in product design review. And then the knowledge that they will need to know is C++ or scripting language. Yes, they use scripting to automate their process actually. Okay. Okay, this is all my sharing. I think I have over time for the half an hour. Sorry about that. So anyone have any questions?
Okay, thank you so much, Mr. Lau Ziwei, for your sharing sessions regarding on the machine visions. And I'm sure our students have gained some knowledge regarding on the concept of machine visions just now, on the applications of this machine visions in industry, for example, even the fundamentals part of machine vision covered as well, right? So anyone have any questions to Mr. Lau Ziwei before we put the sessions? Anything that you wanted to ask?
If you're interested to intern with Vitrox,
Yeah.
or you interested to intern in my department,
yeah, can ask anything. I just wanted to know, Mr. Lau Ziwei, because you mentioned about the deep learning concept just now, right? So so in the machine vision itself, is there any like specific methods of deep learnings and also like feature extractions that you guys use in a machine vision?
Okay, for machine learning case, actually it's a customer specific.
Okay.
Yeah, for different customer, we have different AI model because their product looks different, and the things that they want to capture is also different. So we will actually train the AI model based on their requirement. Still, we also will try to provide a generic model like to capture crack, to capture foreign material. But maybe if that generic model unable to cater their needs, then we need to extend to train a newer model for them.
See. What about the data? Is it I mean, like for me, like as a researcher, right? And even like if is there like any data available for like the researchers or even the students just just wanted to play around with the data using like AI techniques, etc.
You mean our company data? I think for now
Yeah.
still proprietary. Still
Okay.
proprietary. I'm not sure whether we will open source it.
I see.
I think won't lah, because this is customer sensitive.
I see.
Confidential. Yeah.
But do you guys work with like local university as well? Like for example, like maybe like in Penang, like USM or
Yeah,
this
correct. We have a
research.
Vitrox Academy,
Uh,
and we have I think we got in fact some USM lecture or what they come here sharing, right? If not mistaken.
see. Okay, so we have a
Okay.
questions here. This is from
Okay.
Nelson. If there's any accommodations provided, if any internships for the interns, accommodations.
Accommodation, I think no, but
Okay, I think so. Wait, you want me to
yeah,
give you?
maybe. Okay.
Okay. For accommodation at the moment, we didn't provide for intern and also permanent employee, but what we can help is like we can assist you in providing the link for you to search for accommodation and help you to ask around. But the cost we didn't bear at the moment.
Is there any like allowance provided for the students? Allowance?
No, but we provide free lunch.
Free lunch. All right.
To compensate other saver lah. But for accommodation, not at the moment.
Sure. All right. So there's another question from Shin Yong here. So my friend conducted an interview with the company, however, was not able to get the positions. Perhaps what could be the criteria that the Vitrox could be looking aside from high CGPA, like big N, Java, C++, or is there any like specific skills that you're looking for apart from the high CGPA?
Mainly you want to answer or
I think it's more towards to technical, right? I can cover a little bit on soft skills. If let's say for soft skill wise, then we'll be actually seeing on the attitude. Are you having a very good learning attitude and willing to learn? And are you willing to go extra mile? Are you a team player? This is some of the soft skills side that we are looking into. Lah. But for technical skill wise, I think is you can take the questions right. If let's say talking about like related to software.
yes.
Yeah.
Okay. So besides the knowledge that we want, okay, of course, if you have very good knowledge on programming or machine vision, then that's a bonus. But actually, what we look at is the learning attitude first. And the second most important thing is the ability of the candidate to observe what is the problem and think of a way to solve the problem. Yeah, because we believe that 99% of the problem there's answered. You just need to ask the person you know. Okay, so I think it's maybe it's due to the interview performance, perhaps if the technical is not the issue. Yeah, and you need to show to the interviewer like you are very passionate in your project and how you actually tackle different problem in your project, how you find a problem, how you define your problem statement, and how you actually finding the solution to your problem. Yeah, they don't want to know your problem solving mind. If you have that problem solving mind, then you are qualified already, I think. Yeah. Not just theory, this thing. It's a thinking, it's a mindset. Yeah. I think the proper way to say is a growth mindset. Yeah. Growth mindset.
I think even for employment as well, not just for internships. I think
Yes.
most of the company that are looking for this growth mindset as well. As long as you wanted to improve on yourself, you wanted to always wanted to learn, right? Yeah. Any more questions? Okay. There's a question from Rahul, but I think mainly we'll answer the questions to Rahul, right? Any other questions before we complete the sessions? And also, I wanted to ask because you mentioned about the position just now, right? Because you have this full stack developer, you have this AI, and also you have this tester. So for the internship itself, right? So do the students get to choose what sort of like okay, if I'm interested in, for example, in a software tester, will I be in that department or will I be in, or it will be like a rotation for different departments?
You will need to mention to your interviewer, of course, because interviewer, when they interview you, they don't know your intention. So you need to show that, wow, I really want to try this role, and they will try their best to fit you inside the role. Or if they think your skill is better for the other role, then can discuss. Maybe he will persuade you, or if you still want to continue with that role, yeah, maybe he will let you try.
Right.
Yeah, I think it's actually this is the communication things. You need to show to your interviewer that you are very interested in this role. But I think most of students doesn't really know what are the career available. I think you need to
Yeah.
look at the Vitrox.com website. But even Vitrox.com website, I think still very less because this field position is based on my experience here. I add on one.
Normally, the interviewer, so-called the managers, they will be, during the interview or assessment times, they will be actually assessing the candidate, especially intern. So they will assess based on, is it the suitability for each role set? Maybe, for example, software development, software team, and in there they have Shabang. Then probably he will assess and then see whether which team that he's suitable. Then he will part him in. So definitely need to go through assessment. But normally students, they won't be really know what they want when they are looking for internship. So it's like everything is considered as a very good exposure, I would say. Yeah, just give it a try and then you learn whatever you can learn as well as many as you can. Yeah, this is a thing.
All right. Okay. Any more questions from the students? Anything you wanted to know? Okay. So I think if there's no more questions, if let's say you have any other inquiries, mainly I'm sure that they can reach out to you, right?
Yes.
The questions, yeah.
No problem. Maybe I just
Yeah.
leave my email address here, then
Yeah.
they can just reach out me.
All right.
Okay, everyone please take note, yeah, in the chat box.
All right. Yeah. So you can
Okay,
yeah.
connect with me at LinkedIn. Yeah. Okay. This one.
Yeah.
I'm
All
not
right.
sure
So we
whether
have.
doctor do we need to take a group photo before we end.
You want to? Yeah. Sure. So everyone, can you open up your camera so that we can take a good photo?
It's probably you might need to unshare a screen.
Yeah.
Okay. See how do I share? Stop. Okay.
Can you guys open up your camera?
532, you are a boy. Okay.
Can you guys open up your camera? A few of you.
Doctor, who shall take the photo? Your end or my side?
I can take the photo as well.
Okay.
Right. So if you understand. Any others? Can you guys open up your camera? If it opens. So we can just proceed lah. Okay. So, okay, 1, 2, 3. Okay, the one. 1, 2. Okay. All right. Thank you so much. Once again, on behalf of FCS IT and University Mrs. Sarawak, thank you so much to Ms. Mili and also to Mr. Lau Ziwei for sharing your sessions regarding Vitrox company with us. And I'm sure after this, if you have any questions, and if you don't have any questions, they can reach out to you. And we thank you for these sessions. And also, we hope that we can get more uh, connections and also more sharing sessions from Vitrox in the future. Okay. So I think that's it from my side, from Unimas.